Bohr's Model of the Atom by Jody Franken. What was it like before the Bohr model? By the 1900s, scientists became very confident in explaining how big things were able to move. Things like planets, or cars, or even common objects such as a basketball. However, tiny objects weren't as simple to understand, such as the atom. Of course, it wasn't until 1913 when a physicist by the name of Niels Bohr came up with a new concept. He combined previous ideas of how objects move and interact with newer ideas based on energy. In other words, he combined classical physics with newer quantum energy concepts. This allowed us to observe what was actually happening within the atom. Neil constructed a model known as the Bohr atom. His model explained why hydrogen atoms give off certain colors of light. These colors of light are known as spectral lines. In the Bohr's model, electrons, which are tiny particles with negative charges, orbit around the nucleus. However, the electrons aren't allowed to just freely bounce around. No different to a runner on a track, each runner is given a designated lane to ensure the runners don't collide. In the world of atoms, this is called energy levels. The track-like design is so electrons don't spiral and collide into the nucleus. The lower the energy level, the closer you are to the nucleus, or in the runner's case, the center. The higher the energy level, the further. The Bohr model allowed an introduction to a new important idea, quantized energy levels. This means that electrons can only be within certain orbits, or lanes. Each lane has a set amount of energy. As previously discussed, electrons can't just switch lanes. However, they can jump into other lanes, so they are never crossing over or getting stuck in between lanes. When an electron jumps into another lane, which is always that of a lower energy, the change produces a small bit of light called a photon. The light's colors varies depending on how much energy is given off during the lane change. To help us find out the amount of energy that is emitted, this equation was created, where n is the principal quantum number and E is the energy of the photon. To summarize, when an electron jumps into a lower energy level, a photon is emitted. The color of the light emitted and the size of the energy wave, called a wavelength, depends on the energy given from the jump. Looking back to hydrogen's spectral lines, the colors are actually just showing us the changes of energy as electrons jump into lower level orbitals. What did the Bohr model achieve? 1. The Bohr model explains spectral lines and why certain colors appear. 2. It helped provide a foundation for scientific advancements in the study of light within atoms. This is called spectroscopy. And finally, 3. It led to the famous Rydberg formula that allows us to predict wavelengths of emitted light. This is the Rydberg formula, where R equals 1.097 times 10 to the 7. There was only one issue with the Bohr model. It only worked well for hydrogen atoms because it only had one electron. The model did not work with other atoms containing more than one electron. However, the Bohr model led to quantum mechanics, producing a much better theory for explaining different atoms. Scientists discovered quantum numbers that allowed them to describe bigger atoms, as well as understanding why certain elements behave the way they do. This also extended to helping nuclear physics, and the theories later on helped invent the first laser. Niels Bohr helped take a big step towards understanding the functions of atoms. The Bohr model may not have been perfect at the time, but it certainly helped create a path for future scientific advancements and discoveries. Thanks for watching.